discuss about routing policy. What is a routing policy? Then we have introduced the routing policy specification language, RPSL, and we have given you some example to show how RPSL can be used to write your very simple routing policy, right? Then we saw the routing registry database, how they are spread across the world and how they are interconnected, and so that in any of the routing registry database, if we update our routing policy in RPSL language, that can be reflected to other IRR database. Then we did little bit of discussion on WHOIS database, and we saw the WHOIS database objects, and we saw some of the objects in the WHOIS database related to internet registry, and some of the WHOIS database are related to internet routing registry, right? Route object, auth-num object, route set object, AS set object, those all are related to routing registry database. Set objects are very useful if we need to scale in a bigger environment. So set object actually help us to simplify the creation of the script to automate the whole LOA check process. Now, after the break, what we will be discussing about some practical case studies in terms of RPSL, how RPSL can be effectively used to represent some of the policies that we saw in the internet. So, using RPSL, we can implement our peering policy, we can implement our filtering policy, we can implement our backup, multi-homing, all the other policies. Now we'll discuss about peering policy, how we can write. What is the purpose of RPSL before we go and write it? Before the break, we discussed the purpose of RPSL is to write your routing policy in a close to human language, right? And then we publish that policy into a database. After we publish that information into the WHOIS database, then the second process is the router who will implement that policy, or in a machine where we will implement that policy, they need to look into that and bring it down to their devices, right? So that is the purpose of it. So far what we discussed is to represent our policy into RPSL. Then after that, probably we will introduce you to another tool. Using that, you can automate the process of getting those published policy into your network and apply that onto the router and then make it work, right? So before we go and discuss detail of different case study, we need to be familiar with some of the tools and operators that we use to select and use into our RPSL syntax. First of all, that hat and minus sign, what does it mean? Those are all regular expression, I believe. Some of you are already familiar with that. If not, then just, if you're familiar, probably we'll just revisit those. It's refreshing for you. Otherwise, for the new people, you'll have an idea what are those. This regular expression, those are context insensitive, right? Okay. It means it's a generic syntax. So for example, hat and minus, if you specify these things with any of the prefix, say for example 128.9.00/16 hat minus, what does it mean? It means if you specify these things on any of the prefix, that syntax tells within this prefix 128.9.0.0/16, within this prefix only prefix that are /16 will be matched. Only the prefix that are /16 will be matched, right? That excluding this prefix 128.900. Other than that, all the prefix will be matched. Hat plus means same thing but including that prefix. So for example, if you specify this one 5.0.0.0/8 hat, that contain all more specific, which includes this one plus other /8 within the range. If you specify more generic one, hat n, that means within the prefix what you specify, and then n is replaced by a number, which means within that prefix from /8, all the /16 will be matched. All the /16 will be matched. Okay. If you do n minus m integers, so for example, this prefix /8 had 24 minus 32. It means within the range, all the prefix will be matched. Within the range, all the prefix will be matched. So then another regular expression to match your AS path. So as you see, in internet routing registry system, you need to specify the prefix as well as the AS numbers. Right? Both you need to match to implement a complicated policy. So how to match your AS numbers? That's what the AS path regular expression. The previous one was address prefix match regular expression. So in this regular expression, we will see what are the examples that we have. Say, in the AS path regular expression, the dot character will match one character within the string. Match one character within the string. Star match any number of preceding expression. Plus match at least one preceding expressions. Hat is the beginning of the line. Dollar is the end of the line. Let's see some of the example in here. Say if we write any regular expression that is within those two brackets and AS3. So it means route, all the route we are matching using this regular expression. All the routes that we are matching with this regular expression that has got AS3 on their AS path. All the prefix will be matched who has got AS3 on their AS path. Hat AS1, it means all those prefix will be matched where the AS path is beginning with AS1 or starting with AS1. All the prefix will be matched where the prefix is beginning with AS1 at the beginning of the, sorry, which prefix match where AS path is beginning with AS1 on the AS path. And then if you specify a $sign at the end of the AS number, it means it's matching the route whose AS path end with AS2. So did you see all those logics, how we match AS path? then had AS1, AS2, and AS3. What sort of string it will match? It will match the exact AS path where strings start with AS1, AS2, and AS3. Okay. Had AS1 dot star AS2. It means AS2 path starts with AS path. That AS path start with AS1 at the beginning. At the end, it will be AS2, and then any number of AS or any AS at any number of time in between. Right? So AS path starting and ending, and any AS number will be in the middle. This one had AS3 plus $. It means the AS path start with AS3. Then this statement can be any number in the preceding section. So, yeah, those are the common AS path operator string that we use into the RPSL. So, this one can be an example of the use case. If you see the use case in the internet, why we use these strings for, I can give an example of this one. If your customer is connected to you, and if you want to allow your customer to do AS path prepending, then probably this expression could be more meaningful, right? Let's have a look. An example case of it. In an expression, if you have AS3, 5 AS4, it means on the AS path string, it can be either AS3 or AS4. And you just have that AS3 and AS4 in the path, then in the regular expression, then on your AS path, any AS path has got those two AS will be matched. Right? Those are the string that we have normally. Now we'll see an example in here. Common pairing policy, how we will write it using AS path and prefix, and how we register it into our auth-num object. So that is what the auth-num object of AS2. Here is the scenario. AS2 is the transit ISP, AS3, AS5, AS4 are customers. So actually, if you see AS2 customer, AS3 is a customer, AS4 is a customer for AS2. But AS5 is not a customer, direct customer of AS2. AS5 is not a direct customer of AS2. How AS2 will write this policy into RPSL? So that is what auth-num AS2, AS name, sample net, import from AS1. What is importing from AS1? Is importing any. Is importing from AS1 except any. What means? It means he is importing whatever he is sending. If he is sending the full feed, he is importing the full BGP feed. Right? Okay. Import from AS3. What is importing from AS3? Had AS3 plus $. Had AS3 plus $. What does it mean? What AS2 is doing? Importing had AS3 plus $. It means what? Any prefix originated by AS3 and this one means this expression can be any number of times. So it means, sorry, more than once. Yeah, more than once. It means if AS3 is sending AS5 prefix, will that be allowed from this statement? If you see from this statement, AS3 accept had AS3 plus $, it means AS5 prefix, will that be allowed? No. Why? Because when S3 originated any prefix goes to S3, S5 originated the prefix goes to S3, and S3 send it to him. On the S path, on the S path, on the S path, it will be origin S, S5, then S3, right? But using this regular expression, that will not be allowed, because the regular expression is saying S3 can be a number of time. The S path can be S3, 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 but not S5, S3, right? So this regular expression is very generic. If he want his customer to originate his prefix, or he want to do S path prepending. If he do S path prepending, that will also be allowed. Make sense? But if you use this regular expression, had S3 and just $sign, not the plus sign, then what happened? Only from S3 but not S path prepend. Make sense? Okay. Import from S4. What he is importing from S4? He is importing S4 plus $. It means again S path prepend. Now what he is exporting? Now what he is exporting to S3? To S3 he is exporting any. If he is exporting any to S3, it means he is giving him transit for his own prefix. Make sense? So if he is exporting to any to S3, it means he is allowing transit for S3. Same for S4 as well. To S4, what he is announcing? He is announcing any as well. What does it mean? When he is announcing any, it means all prefix, that whatever he is receiving from him, giving it to him. So he can browse this network, he can go internet as well. Make sense? Same from the other side. And when he is exporting prefix to S1, which is the upstream, what he is exporting to upstream? He is exporting S2, S3, and S4. It means S2 his own prefix, S3 prefix, S4 prefix, right? In that case, do you think this guy can use his network to go outside? This S5, because S5 prefix he is not announcing anywhere, and he is not giving any prefix to S5, right? So S5 will not get transit through S4 at this stage. All right. Okay. Now we look at the set object. What is set object? Set object is an object where you can add a number of number within the set. What would be the use case? Before I explain the set object, what would be the use case of set? Say you are a transit operator in Australia. If you are a transit operator, you have a number of customers who are also a transit operator. You are a tier 2 transit operator, for example, right? So when your customer, they will have another customer, and you as a tier 2 transit operator, you need to allow transit for your customers as well. Make sense? You need to allow transit for your customers as well. So by using a set object, You can do that very easily. How you do that? Okay. That is what the AS set object for AS2. So what he is doing, my AS set name has got a standard syntax that you need to follow on the name. Name has to start with the name of the AS and AS customers. And then as a member, you have your own customers' names. Right? Currently, if you have got 2 AS number as your customer, you add those into the AS set object. And then when your transit operator, they will accept route from you, what they will do? AS2 from AS2 customers accept AS2 AS customers. What does it mean? That is what your RPSL syntax that you have used in your router. So your router will always look at this set object. If you are having a new customer coming in today, what you need to do, don't need to change anything on your main script here. Don't need to change anything on the main script. What do you do? Just go and add the new customer. Go and add a new customer as a member of this AS set. As a member, just add another AS number. Right? Just add another AS number. In the evening, another customer, then another AS number. Just increase the member in your AS set. So when your router look into the AS2 AS set customers object, whenever the interval comes to update the cron tab, they'll fetch the new member list from the AS set and allow the transit. Right? Okay, what I am exporting to AS2 customers, if you see export to AS2 AS customers announce any, so by having a single import and single export statement, I can add all my customers now. Right? Before, if you see the previous case study, in the previous case study, what we did, for each customer, we need to have an independent single import statement and single export statement. Right? But now, we just did only one import and export. For all the customers, what I am exporting, 2S customers announce any. It means whoever belongs to that list, whoever belongs to that group, everyone will receive what I am announcing, everything. Right? So by having a single statement, I can add all my customers. What would be the syntax on AS1s? When AS1 want to automate the whole thing. So what AS1 will do, AS1 will add, AS1 is the upstream, like this one. He's the upstream. What AS1 will do? AS1 import from AS2. What I'm importing from AS2? Except had AS2 plus AS2 customer. So if I have this single statement into my import statement, then all the AS who belongs to this AS set, all the AS who belongs to the AS set will get the transit allowed through your network. Right? So the use case of this is, say Telstra, who is the upstream transit operator in Australia, big transit operator, for all their customers, what they will tell, okay, if you have a new customer, you don't need to call me up. When you have a new customer, go and update your AS set object. Just add the new customer onto that AS set as a member. When you add them, in my network, we have already an import statement here, and I'm adding all your AS set customers. That's it. Just update your AS set, my filter will be updated automatically. I don't need to update those things manually every day. Make sense? So this is how in a bigger environment, in the transit operators environment, they can automate their LOA check process. How LOA check process are enforcing in here? If someone need to add any object into those, or any AS numbers into those set objects, this guy definitely need to have his username and password, not username, like maintainer password. Without maintainer password, can you update all those records? No, you cannot, right? And if you are going to add any member there, you see that, a maintainer relationship, those relationship has to be there as well. Otherwise, you cannot just add anyone in any of the asset group. So, by ensuring all those hierarchical maintainer authorization, then only you will be able to add those AS as a member, then your filter will be updated. So this is how IRR, Internet Routing Registry Database, is ensuring the LOA check into the network. Okay, how we can limit routes as well. So for example, AS2 and AS3 are connected. AS3 has got a prefix from the registry, 7.7.0.0/20 allocated by the registry to AS3, right? So what AS2 can do, AS2 can add a routing policy, and on the routing policy, what AS2 can do, allow this prefix only into the import statement, like this. AS2 import statement, that's what AS2, his import statement in auth_num, import from AS3. What I'm importing from AS3, prefix 7.7.00/20, 20-24. What that means? It means from AS3, whatever the prefix I'm accepting, whatever the prefix I'm expecting or accepting into my network, that need to belongs to this subnet and within this range. So this syntax is even more, strict than our AS path. In AS path, what we did, we just checked the origin AS. In AS path, we just check the origin AS. Whatever the prefix coming from this origin AS, we accept it. And if that AS, they are sending any wrong prefix by mistake or by intention, those will be allowed as well. The previous one, did you see the AS path? So if we just work on the AS path, then any prefix coming from this AS will be allowed, and that includes illegitimate prefix as well, if that downstream AS doesn't do those LOA check properly. But this one, very strict, only that prefix, right? So if you see the scale, how we can scale in a big environment, normally in internet, tier 2 or tier 1 ISP, when they do their filters are based on AS, origin AS. So from which AS it is originated or via which AS the prefix are coming. So that's how those big transit operators, they only rely on their customers' AS numbers. But when that question comes to the further down, what their responsibility, for example, on tier 3 ISP's responsibilities, they should check the LOA for the prefix. So if you glue all the things together, tier 3, their responsibility is to check the prefix from each customer by having those sort of statement, check the prefix from the customers, and when they check the prefix, tier 2 and tier 1, their responsibilities are not to check the prefix, but from which AS is coming. Right? From which AS the prefix is coming. So that's how the LOA check functionalities are implemented in every part of the internet. And if all the operators, tier 3, tier 2, and tier 1, they implement those LOA check procedures properly then probably will not have those prefix hijacking case in the internet, right? Okay. So when you are able to represent your routing policy by having those RPSL and publish it to the internet, then how your router will go and listen to that. That's the second part of it. First part, what we discussed so far, how we publish our routing policy to the global internet. The second part is, after publishing the policy, how your routers are going to listen to it and build their filtering configuration and upload into the router. That's the second part. These things can also be automated or need to be automated as well. And what are the tools that we use for that to automate this part, listening to those published policy? The tools used for that, we call it IRR tool set, Internet Routing Registry tool set. That was developed by a number of groups. ISC was one of them, Internet Systems Consortium, who developed the bind and DHCP software as well. So they were one of the developers as well on that IRR tool set. How you can get that IRR tool set? Just go and download that software from this website. You still be able to download it from their FTP site. Just duplicate that from the FTP site. Then you'll have the IRR tool set in here. You untar it and install it into a Unix machine. When you install it into a Unix machine, then you'll have an rtconfig utility, a tools installed on the path, rtconfig. That rtconfig tools or utility can be used to build all the filters for the router. So in rtconfig, if you do rtconfig whois -h, and then you can see all those. You can specify even the whois servers here. You can even specify the whois servers here. So if your router is listening to RADB, then your whois server name will be whois.rdb.net. If your router is listening to APNIC whois server, then it has to be whois -h whois.apnic.net. If your routers are listening to any other RADB, you need to know the FQDN name of that RADB's whois server. Most likely case it is whois dot their domain name. But you need to check. So when you run that tools, then you can see all those policies will be fetched from that published RPSL on the routing registry database. So you need to create an input file. You need to create an input file to build the config for the routers, fetching those RPSL from the routing registry database. So when you build that input file, on the input file for each map or each syntax, you have to have add rtconfig and set. So did you see those input file can be used for different platform. It can be different vendors product. If it's Cisco specific config, you have to specify Cisco's map name and the name of the maps and all. This is how you specify that on the input file. For Juniper, you have the Juniper specific syntax, right? So when you download the rtconfig, you need to download it on the vendor's product which you are using, either Cisco, Juniper, or whatever the routers you are using. Then from that, when your input file is ready like that, then you can generate your output file from rtconfig. So when output file is ready, so that output file will have all the configuration equivalent to either Cisco or Juniper or any other router. So after that, how you upload that config into the routers? After that, how you will upload the config into the router? For that, you can use a number of ways to upload it onto the router. It can be SNMP, it can be netconfig protocols, or XML-based protocol, or any other script that you are using to upload that into the routers. And for that, you need to consult with your vendors what API they support. Normally, people use XML base or SNMP base. So this is how you can upload those config into the routers. So if you see the process, all those scripts that you are preparing, and then from there you are creating those input file, and from the input file you are creating the equivalent config file specific to the vendor product. When the config file is ready, then it's your job to upload it into the router. So those process in IRR system normally done using a Unix box and process to automate in time-based manner. So in certain time of the day, you upload or you generate the config file and upload it into the router. It depending on how frequently you have your customer into your network. Some of the operators, they do it once a day. Some of the operators probably more than once a day, depending on how frequently you have your customers coming in. Okay. So that's what our IRR, Internet Routing Registry database. Any question? As we can see, IRR, Internet Routing Registry database, even though the system in place since long before, but because of the complexity of it, lots of steps that we need to do, we don't see widely deployment as of now. Only like big transit operators, they do it, and deploying those things in an automated environment, IRR systems, you need to do lots of customization, customized script. So without your customized script, it's not very user-friendly to implement that. You can have RT-config, you can have all those syntax, but you have to build your own script, a number of script to do that, right? So that's why we only saw those transit operators who has got the skill, support, they implement IRR, but all those tier 1 or small operators, they prefer to do it manually. And when they prefer to do it manually, it creates lots of uncertainty. And that's why still now we can see prefix hijacking case in internet. It happened, a number of times it happened, right? How we can automate the whole thing, how we can make it, automation process is there, but how we can make it more scalable, more robust. Why not routers, they directly can listen to it? Because if you see the IRR concept, in IRR concept, what we are doing, we are building a number of scripts, but those scripts are all done into outside, done onto outside the router, not inside the router. Outside the router, we did all those things, we build the config, then we upload that into the router. So when we can upload it to the router, then only it is activated on the router, otherwise not. So there was a discussion how we can make sure the router itself can do all those things by having some certifications. So that's how the new process RPKI actually came in. RPKI stands for Resource Public Key Infrastructure. So it means we are replacing that LOA check process with a robust, user-friendly way. So when we can implement RPKI effectively, then probably we don't need IRR, right? So in RPKI, what is the fundamental concept? What is that, basic concept, behind that LOA check? In RPKI, the main idea is when IP address has been allocated to any operator, any network, right, by a registry, if we can certify those prefixes using a digital certificate, and publish those digital certificates from a central place where your router go and listen, and by having a protocol, they can check those certificates, and by looking at the certificate, what it is getting, and like, and the digital certification verification process, if the router can determine by themselves which prefixes are not valid and which prefixes are valid, based on that they can accept it or they can deny it, then it's very easy for us as a network operator. So we don't need to run lots of script and manage it, right? So that's the basic concept of RPKI. So in RPKI, the concept is when the registry will allocate any prefix, they will issue a certificate attached to it, right? And that certificate will be published somewhere. And when routers, they need to validate that, they just listen to those certificates and they can verify those certificates within their system and they can tag those prefixes, and based on that, they can accept, they can deny. That's the purpose of RPKI. So, yes, RPKI is obviously more robust, secure framework than your IRR process. So, when we develop or the industry they develop RPKI process, what are the concerns they have? What are the threats? What are the threats? What are the risks that we have in terms of prefix advertisement and prefix acceptance? All are drafted in RFC 4593. So that explain all those generic threats that we have, all the generic threats that we have in terms of managing our routing infrastructure, right? So current RPKI implementation was not able to address all the threats outlined on this RFC. Probably very few at this stage under development, and so far, the industry managed to verify only one, origin AS. There are a number of threats that we have. Out of that, at this stage, the RPKI working group, their initiative is to secure two parts of it, origin AS and AS path validation, and AS path, those two things. But out of those two, only origin AS validations are implemented, AS path validation not yet. So, if you see in internet, the way prefix has been advertised and the way prefix are going across, one of the very important part of it is to make sure the prefix has been originated by a valid AS. One of the very important aspects of securing internet infrastructure is to make sure prefix has been originated by a valid AS. That's what we call origin validation, right? Another part of it is when the prefix has been advertised onto the internet, through which AS the prefixes are propagated. That is what another things. Through which AS the prefixes has been originated. Why we need to build that trust? Because that is how the customers and service provider relationship has been built. If you have a network connected in here, and if you have got a trust with your upstream like Telstra, any business trust or any contract or any SLA with them, your prefix will be allowed through that particular AS. That's what the common logic. If your prefix is advertised through another AS where you don't have any trust, that just the prefix has been linked to that AS, right? That need to be protected as well. So that is what we call AS path validation. When we originate any prefix, when the prefixes are advertised through a number of AAs, if those trusts are built, then only prefix will be accepted. If the trust has not been built, then it will not be accepted. This AS path validation still under development process in ITF. But origin validation is already implemented and is available in the product, Cisco or Juniper. We'll see that. Okay. What benefit we'll get from RPKI? I think the similar benefit, but in a robust way. What benefit we are getting from RPKI? If you compare it with IRR, I think similar benefit, but in a robust way. That will even prevent from your route hijacking case, right? And that can be intentionally or that can be by mistake. Can you remember that well-known case like YouTube case? Some part of the network YouTube prefix was advertised by mistake, right? So RPKI can stop those mistakes. Or if someone is doing by intention. So the whole RPKI development things are done in ITF SIDR working group, secure BGP working group. So this working group in ITF actually developing this product, RPKI, by the name of SIDR working group. So as I said, this working group currently working on securing two things. One is prefix origin validation, other one is path validation. Path validation, as I said, not yet. Let's concentrate on origin validation at this stage. So in RPKI, there are three parts of it, three components of it, main three components. Number one is our certification authority, CA, who will certify the prefix. Number two is the relying party. Relying party means one party, say for example the registry, RIR, they will allocate the prefix, right? When they will allocate the prefix, they can certify those prefixes, yes, it has been given to you, right? They will have a system in place. And then relying party means when you implement or when you check those certificates, before you accept any prefix, right, you should have some system in place to check those certificates from your place, from your network. That's what the relying party is. And then the routers who will listen to the relying party will have the RPKI support or need to have the RPKI support, right? So initially, if you need to relate that concept of RPKI into a existing services that we have in internet, same like like DNS, mail, web, right? How you do it? You are running your own DNS server into your network, right? You have a chain of trust built already. There is a root server, and all the way is coming to your DNS. So all your customers within your network, when they need to resolve any query, they go and look into your DNS, right? And that DNS is linked with the other DNS, it's a distributed architecture. So somehow it has been resolved, right? We know that how DNS works. In RPKI case, I think similar thing will be happening. In future, if you want for the scalability into your network, you can run your own or you can maintain your own relying party software or RP software. You can run your own Reliance party software or RP software. Or you can rely on someone else. For example, APNIC as a registry, depending on you. But normally, as I said, to make it scalable, to make it very easy for you, you can run your own RP cache. And then your router will have a protocol running inside called RT protocol that will support the router to talk to the RP cache and get those valid certificates and allow transit, right? How many of you already did little bit of RPKI? Did you see your BGP table after you implement the RPKI, how it looks like? Normally when you see the BGP table will show you all the prefix with some attributes of BGP. But after you implement RPKI image, like SIDR image, then you'll see, apart from your normal attributes that you have in BGP, there are some additional tags coming on, right? We'll show you, we have a screen capture here. Okay, issuing party. Normally the internet registry, they are the issuing party. Normally. So for example, regional internet registry, for example, APNIC, National Internet Registry, NIR, or large ISPs, they can run their own certification servers, and they can certify those prefixes. Okay? At this stage, APNIC has already implemented that, and APNIC is running those certification servers for RPKI. So all those certification authority, when they allocate any prefix, they provide an user interface. Through the user interface, you can create those relationship between your IP address, AS numbers, right? And sign it by your keys, right? When you sign it, which key you use to sign it? Digital signatures. Normally using your private keys, right? And then you publish those from the publication servers. So that's what we call ROA. Route Origin Authorization, I think. ROA. So the bottom line is, if you have access to my APNIC, go to my APNIC and create an ROA. On the ROA, you need to specify the origin AS, from which AS number the prefix has been originated, right? And definitely when you go to my APNIC, you only can see your own prefixes. You cannot see someone else's prefix. So those prefixes you originate from your own AS numbers, and then from my APNIC, you publish it, and it goes to APNIC RPKI engine. And when it goes to APNIC RPKI engine publish those things into the repository called RPKI servers. So within these RPKI servers, all those ROA are published, right? Yep, so the ROA is a digital object that contains the list of addresses that you have. The list of address that you have and originating from an AS number. That's what an ROA. So this is sort of a certificate that attached to the prefix. That certificate is X.509 standard certificate with little update. X.509 certificate with an update, extension 3779, that supports you to interrelate different objects within the certificate. Before that, it was not possible, but after the update, you can interrelate a prefix with an AS numbers, right? So interrelated certificates that you can create using that extension. And that contain owner's public key for the verification purpose, right? So when you sign something with your private key, to check that, how you do that? Using your public key, you verify the signature. So the relying party, so all those RIR, Regional Internet Registry, when they receive the prefix, they are interconnected. So whatever the ROA are published is going to the other repository as well, right? So from there, those published ROA are here with a certificate. But when router will listen to it, router will not understand all those things. Router just need to know whether the certificate has been valid or invalid. So that validation will be done by all those RP cache. You see the RP cache, they'll go and collect those ROAs. They'll go and collect those ROAs. So comes on the RP cache. So routers, when they listen to those ROA, they'll just go and listen to this RP cache. They don't need to go and connect to that RPKI repository to validate those. Already validated ROAs will be published or will be sent to RP cache, and in RP cache it will be a plain format validation. And then routers, they'll go and talk to those validated cache and get those valid, invalid certificates into the routers by having a protocol called RT or RTR protocol. So if you see that diagram, what is your job to implement RPKI? Your job is you need to have a routers that support that RTR protocol with SRDR image. Then you need to have a cache somewhere. You can build your own cache, like the way we manage our own DNS server in our network, right? We can manage our own DNS server. Same way in future, when you need to deploy RPKI, you can have your own cache into your network, right? So if you're running your own cache into your network, it's very easy for you to listen to those cache. If you have 10, 20,000 routers into your network, all the routers will go and listen to your cache servers, RP cache. And from the RP cache, it can get all those validated certificates. And the job of RP cache is to sync all those certificates into the publication servers or with the publication servers. Okay, so our experience is much easier or convenient to run your own RP cache. You can download that software. I'll show you the URL from there. You can download those RP cache software. You can build your own cache the way you build your own DNS server. Just when you build your own cache, then that cache will talk to the repository. When you talk to the repository, you can talk to a number of repositories. It can be APNIC publication server, it can be ARIN publication server, any of the publication server you can listen to. And then from there, you can get all those certificates, ROAs, into your network. And then from there, you deliver the routers only those simplified information to the routers, either valid, invalid, or not exists. So router don't need to do all those complicated certificate validation. RP cache will do that, and router will get only those validated ROAs. So APNIC RPKI engine, we have a number of publications, and from there we also have got an RP cache as well. APNIC also maintain an RP cache. So if you don't want to build your own cache servers at this stage, you can rely on APNIC cache server as well and connect your router with the APNIC cache. And as I said, since APNIC cache is far from your network, sometimes you can have some instability if your network is not good. Or in some case, people don't prefer their router to talk to the external server to get the validation. They would like to manage their own cache so that within your internal network, you can trust those. Okay? It depending on your plan, how you want to do that. In APNIC provide RP cache as well. APNIC provide the publications as well. So you can use any of that. If you're building your own cache, then you can listen to APNIC publication server. Or if you don't want to, you can listen to APNIC cache, RP cache servers from the router directly. How you do that? When you enable your router to work with RPKI, I'll show you the command, just very simple. Then on your BGP table from the cache server, all the prefix coming to your router will have any of those three tags: valid, invalid, or unknown. Valid means those prefixes with the tag valid. It means the ROA are available into the publication server, and the origin AS is the correct AS. Correct AS allocated to that particular operators and originated from the correct AS numbers. So that's what our valid ROAs. Invalid ROA means that ROAs are existing, but it has been originated by an invalid AS. It's not matching. The certificates are not matching. That's what are invalid. And the third one is unknown. It means no ROAs are created. Publication server doesn't have any information because you haven't created any ROA. So if you look into your BGP table, it looks like this. This is what the looks of a BGP table after implementing RPKI. And you'll see those tags here with every prefix. I stands for invalid, V stands for valid, N stands for not existing. So these RPKI supports are available on those vendor products so far. Cisco iOS image 15.2 that support it, XR 4.3, Juniper shipping from 12.2, and other vendor still developing it. How to start? If I want to implement RPKI, how I can start from the scratch? Simply, what you need to do, you need to activate RPKI cache on your APNIC if you are in the Asia Pacific. And to do that, you need to have a digital certificate from APNIC. And then when you have activated RPKI engine in your APNIC, then you can go into the resource section of APNIC and you can create the ROA from APNIC. So when you create the ROA, you can see your available prefixes. You can't use someone else's prefix. Only those prefixes allocated to you can use there. Then you specify your AS number, and then you create ROA and you publish it. So when you publish the ROA from APNIC, it goes to APNIC publication service as well as other registry publication service. Then you need to look into your relying party side. What is the relying party side? Your router need to have a functionalities to listen to that ROAs. And for that, you need a cache server. So you can build your own cache, as I said, or you can use APNIC cache. How you can build your own cache? This is what the URL that you can use to download the source file to build your own cache. Just go to rpki.net, rpki.net. From that website, you can get a link to download the cache image. And that cache image is currently available for Ubuntu only. I think in our APNIC event, past event, Randy Bush, who is one of the person involved in developing the RPKI systems, he was running a BOF, how to build cache. I think those informations are available on RPKI website. Or if you, this time probably you are not doing anything, but just make yourself available on any of the future event where we demonstrate how to build cache. It was a bit patchy initially to build a cache. Slowly it's getting simpler. So when you finish building the cache servers, then what is the final step? Final step, under your BGP, you need to specify the address of the servers and some other parameters for BGP. So you can specify more than one. Then when you put these things into your BGP, then what your BGP will do, try to communicate with those servers, those cache servers, and get those validated ROAs, prefixes, right? So then what happened, when your BGP will accept any prefix from any of the neighbor, when your BGP will accept prefix from any of the neighbor, they will validate those prefixes with those ROAs, valid ROAs. What are the origin prefix? Is it valid? It comes. If it's invalid, it will still come. If it doesn't exist, still come into the BGP table, right? when it comes to the BGP table, then what you do next? When it comes to the BGP table, then what you do next? Next step is you need to tell your BGP how to use those. At this stage, by default, Cisco router will use all those invalid prefix, valid prefix, and normally the way BGP works, right? You can create route map. And by using route map, you can influence BGP's path selection process. You can tell BGP whatever the prefix has got valid ROA. You can tell BGP whatever the prefix has got valid ROA. You can install that into the routing table. You can send it to the next neighbor, right? Whatever the prefix doesn't have ROAs, you still can use it. Whatever the prefix has got invalid ROA, you can downpref those. Or you can even block those. It's completely up to you using route map. There is a command in BGP. So if you do this command in BGP, then what BGP will do? It will only accept the valid prefix. Other invalid, not existence prefix, they will not accept, and then put into the BGP table. But that's too, like, dangerous at this stage, because if you do that, some of the prefix like non-existing, like doesn't have any ROA, valid ROA. It doesn't mean those are invalid prefix. Probably they haven't created the ROA yet. They haven't deployed the RPKI yet, right? So at this stage, we would recommend only use route map, and using route map, you can high pref valid prefix, down pref invalid prefix, and use non-existent prefix, because that doesn't have any information yet. All right, so I think that's what we had for today. Any question? Yes.
What is the percentage of networks who has used this?
Commercial deployment or test? Commercial, I think, is close to 0. But test, there is some, very insignificant. But commercial deployment, I haven't seen.
Except these configurations, router configuration, anything we have to do, other configuration in the router?
Except this relying party. Yeah, as I said, relying party will just tag your prefix into your BGP table. Like this way, they will tag it. Yeah, that is what the configuration. When you do only this configuration, it means you can only see the tag into BGP. But tagging in BGP means, or it doesn't mean BGP is filtering those valid prefix at this stage. It's just a tag, right? This is an optional BGP attribute. Those RPKI tags are BGP optional non-transitive attribute, right? Optional non-transitive attribute. That's why those tag only within your own routers. Router don't pass it to the other routers, those tag. And if you don't do any filtering based on the tag, by default BGP will just tag it and use that as it is. Normal BGP uses. Even invalid prefix BGP can use, even though you have implemented this RPKI. If you want to filter it out, invalid tag prefix, you don't want to use it, then you have two options. One option is you create route map. By creating route map, you can filter those, right? Or the second option, you can tell BGP, single command, no, just invalid prefix, discard those. But that is too dangerous at this stage. So to answer your question, this command is only giving you the tag, but not actioning it now. To action it, either you can use route map, or you can tell BGP not to use those tag prefix. Any other question?
What will be the IP address or domain name for APNIC, this RPKI server?
RPKI.apnic.net.
Okay.
RPKI.apnic.net. Yeah. So if you have any further question about RPKI or IRR, feel free to come to APNIC Help Desk. APNIC Help Desk, we run it from 9 a.m. till 9 p.m., extended hour. And obviously this Brisbane Standard Time, GMT plus 10. To talk to Help Desk, you can call them, or you can come to APNIC's online chat. We have online chat service. The link is not here now. Online chat. And in Help Desk, the Help Desk people can speak other than English. We can speak a number of Asian language. If you want to speak in some other language, ask the Help Desk people which language you want to speak to. All right, so now we have Q&A for 10-15 minutes. Otherwise, that's it. Any other question now? Okay, so after the lunch, we'll start our inaugural for the whole conference. We'll be in the other room, big plenary room. So we'll have two keynote, opening ceremony keynote, and then technical keynote. And if you can see our program, there will be a number of distinguished speakers in the technical keynote. And today we have a social event after the conference. So thank you very much. Thanks to listen to us, staying in this class for the whole half day. And you'll have, I hope you'll have our lunch served in 10 minutes and enjoy the lunch. Thank you.